The Yokohama port terminal, designed by foreign office architects in Tokyo, has transcended the traditional boundaries of transit hubs, becoming a paradigm for understanding spatial fluidity and continuity. Finished in 2002, the terminal's design abandons the conventional direction-oriented spatial layout, instead adopting a fluid and dynamic organization of space. This approach not only reflects the complexity of the contemporary urban environment, but also responds to the needs of future city life in a more pragmatic methodology to the approach of architectural development.
The style of the terminal can be considered as parametricism, a style recognized as being avant-garde and technologically adapted. The uprising of parametricism occurred during the modernist movement in architecture, and as P. Schumer says, it succeeds modernism as the next long wave of systematic innovation. The defining concepts of parametricism include shared concepts, computational technologies, formal repertoires, and tectonic logic. Exemplified in the terminal, parametricism is, aesthetically, the elegance of ordered complexity in the sense of seamless fluidity.
While there is truth behind this sentiment of revolutionizing a new way of developing and utilizing architecture, the terminal also was designed with respect and reverence to the customs of the Japanese architectural vernacular, prioritizing congruous and sociable qualities. With an open, multivalent layout that allows for human autonomy while meeting specific functionality contingencies, the terminal fits within the cultural context of having life and openness in architecture, acting equally as a window of the past and as a window to the future. Spatial fluidity is present in the design through its incorporation of vast and seamless spaces, contributing to the establishment of a clear design theme and the congruency of the overall aesthetic. This unrestrained and unobstructed design language contributes to the feeling of the static structure having movement and spirit.
A specific way that this is done is through the harmonious blend of interior and exterior spaces, contributing to the lack of apparent forced enclosure and the connection of the people to the space. Along with consideration of the interior and exterior, through the construction of the Yokohama Port Terminal, the environment played a significant role in the design and choices of foreign office architects. Concepts such as the identity of the space as a transportation hub and the blending of the environment with a built structure were all focal points in the development of this project.
The streamlining of the Great Tesla building refers to a form of design that minimizes the resistance of the building to fluids, such as air or water. This concept is often associated with traffic design, where aerodynamics or fluid dynamics play a crucial role. The aim is to reduce drag and increase efficiency. In architectural design, streamlining can also be used to create a sense of fluidity or vitality in a structure. The space of the Great Tesla building was a fundamental consideration in the design. The effective use of space is very important, which involves the aspect of space planning, function, and aesthetics. Instead of the typical post and beam structure that can be easily replicated, the terminal building is constructed with a large span arch steel structure. This creates a flexible, column-free space with a seamless transaction between the interior and exterior. As a result, it can be used both as a covered public space and for a variety of purposes beyond travel. In this multifunctional space, all mechanicals and baggage handling units are designed to be concealed within the structure and rise timber floor system. The queues function as entry or exit borders and are assembled as mobile units on wheels, reversing the typical rigidity of border control arrangements and allowing the terminal to function beyond its regular function. Through this combination of structure, flow, mechanical services, and material finishes, the terminal conveys planes, openness, and laxity, and efficiency in the parking areas, curves, fold, diagonals, symmetry, and utility in the terminal floors.
This is the profile study model. And according to the elevation pictures, we can see there are really good flow during the whole horizontal model. Eventually, the whole building was divided into 3 vertical levels. First, the roof. The roof is just about those people relaxing and watching the views. The second floor is more functional, like they have the restaurant, have the shops, have like some halls over there, and people can like spend their time like just travel there. But the first floor is just for the transportation, like there's a parking, elevator, and something like that. And when the building is viewed from this perspective, the original complex plan can be understood by everyone. Just like the picture see, the plan just shows the different functional and like it just looked like a really symmetrical shape for the whole buildings. Structure and materials. However, the realization of such a complex form was a served test for the structure design. The guide by such an extreme concept, the space of building has a great span both vertically and horizontally. If a convenient column network structure was used to realize this, the original simple spatial approach would have been destroyed, which would have been a waste of space. In collaboration with the structure design team, FOA finally adopted a Unicode structure system, a box grinder made of boulder steel plate. Just see below pictures. And steel trusses above the water surface of the terminal, providing the building with the lightness and the flexibility to withstand earthquake, and avoiding the interruption of the flow of space by structure elements such as column and load bearing boards. The roof are ramps, which are surfaced for people to work on and rest, are surfaced with wooden board forming a section of undulating, burial-free public space. This space is also connected to the 2 parks around it on the shore, realizing the continuity of coast ensure an unobstructed view of seahole, and highlighting the natural atmosphere of the outdoors. The ramp as a continuation of the outdoor public space. It holds a concept of the design in its design. The ceiling of interior, the structure system, and the structure form is therefore made of folder metal palm. This has also given the interior a modern feeling that is different from the exterior compared to the wooden material.
One of the last topics we decided to focus on for the Yokohama International Port Terminal was the result of its design and its advantages. The Yokohama Port Terminal was one of the first major projects to fully explore the capabilities of computer design and receive critiques as the largest marine terminal in Japan. It is made up of 3 levels, the first floor being the parking garage, the middle floor containing restaurants and shopping centers, lastly a rooftop level with an observation deck and loads of greenery. Its advantages is that its pattern and intricate designs transfer forces diagonally within the building, which helps withstand earthquakes and seismic activity. Materials that were used in the Yokohama Port Terminal are timber, steel, and concrete, which display effects of flatness, openness, and undulation. One of the most intricate details is the folded metal roof found in the parking floor. The folds help distribute the loads on the building. Another intricate detail is the intersection of circulation patterns, which had broken up traditional linear port designs at the time. The design of the Yokohama Port Terminal allows for ample and usable space for the public and serves as a model design for the future of architecture, in which Rem Koolhaas describes the Yokohama International Port Terminal as an investigation of fluent structure. The freer language makes people feel excited about the things they are familiar with.
In the world of architecture, the Yokohama International Passenger Terminal stands as a striking symbol of progress. This modern marvel exemplifies a profound truth eloquently expressed by Frank Gehry. Architecture should speak of its time and place, but erring for timelessness. This principle comes to life in the Yokohama terminal. Here, parametric architecture, often viewed skeptically traditionalist as a fabulous threat, asserts its significance. Far from being well-run, it breaks through old architecture modes, marrying the spirit of the time with the latest technological advance. The Yokohama terminal does more than redefine architectural norms, it reshaped our collective view of the space we inhabit. It invites us to envision architecture in new, exciting ways. This pursuit of reinvention is at the heart of Terminal's quest for timelessness, setting a new benchmark for architectural design. Today's cities continue to exude the dynamic energy of parametric architecture, embedding both its aesthetics and functionality.